Hello everyone, welcome to today's webinar, Graph Analytics for Insurance Claim Fraud Detection. My name is Yogesh. I'm going to be the speaker for the webinar today. I have around 18 years of experience working in the field of data management and analytics, been working for various Fortune 500 companies, leading their architecture and engineering for products and solutions. Been working in many industries, all the way from finance, healthcare, insurance, hospitality, and few others. A bit of a background about Inferyx. We are a global analytics company and we help enterprise to build AI application, end-to-end AI application using our platform and services. Our mission is to empower enterprises to build these applications where, the scalable and the robust AI-driven applications. The agenda for today is we are going to cover what is graph analytics. We'll provide an overview of the same. Then we can look at the various fraud detection methodologies that are being used in the fraud detection area. Then we'll look at some examples on the insurance claim fraud, and then we can have a live demo if time permits. At the end, we can take question and answers. Graph analytics. So what is graph analytics? So graph analytics is just another type of analytics. Like you have various type of analytics where you are analyzing data for prescriptive analytics or descriptive analytics or predictive analytics. So graph analytics is another area which can help you in the area of predictive analytics. It is all about nodes and edges. So you try to analyze the relationship by creating nodes and edges out of your data. So you turn your traditional or the relational data, which comes in the form of files or tables, and that data gets converted into the form of graph. So it becomes easy to analyze relationships between those nodes. These nodes and edges are nothing but nodes can be a place, it could be a person, it could be an organization, and the edges are basically how they're related, right? So between a person or a customer and a business is really a relationship of a customer, right? A person and a business. So the way person is related to the business is like he is a customer to the business, and so on. So these are the kind of relationships you can build. Now, once you build the whole purpose of doing graph analytics is to run various algorithms that are available as a part of Graph Engine. And these algorithms are quite effective. They're very predictive in nature and they are very scalable as well. So you can run these algorithms on large volumes of data because the underlying technology scales for itself. The major four types of graph algorithms are pathfinding algorithm. This is where you can find the shortest path between two nodes. Let's say you want to visit or you want to travel between point A to point B. And if there are multiple choices available, this particular algorithm will help you identify which is the best path or the shortest path between two nodes or between two places. Centrality is about finding the influential node. So when you look at a graph or basically all these entities, you would like to understand which person or organization is really influencing the problem that you're trying to solve, right? It could be a fraud detection problem. It could be a customer analytics problem. It could be any type of problem. But the goal of the centrality algorithm is to bring your focus to a particular node, which is influencing the most to the problem that you're discussing about. Community detection it's like a clustering algorithm, which allows you to group these nodes into various clusters or communities, and each of this community gets a number. Now you can look at that particular community of interest and then further deep dive into it. So it kind of gives you an area of focus when you look at a bigger graph. Similarity algorithm is finding similarity in nodes. This can be used for various purposes, but one of the use that can come in my mind is this is related to entity resolution, where let's say you have the same customer defined more than once in your data. And if you want to identify if these two customers or three customers are the same customer, so you can take these attributes and compare them using one of the algorithms, and then basically find what is the similarity between these three people, like, is it like 50%, 60%, 80%? And then by defining a threshold, you can say that, okay, if the similarity is above 80%, then I would treat them as a single customer. So you can collate these three people into one person and that becomes your customer. So that's the use of similarity algorithm. There are, talking about the fraud detection, there are various methodologies that are used in the industry today, whether it is finance or insurance or any other industry. The most basic thing is the statistical analysis, right? The first thing you really do when you look at your data, you try to analyze it statistically. You use all sorts of descriptive statistics, inferential statistics, and then you come to know, like, what is the distribution of each of these variables and what are the outliers and things like that. So this is more to understand the data in the first place. Once you have an understanding of the data, then what you can do is you can start creating some business rules using some rule engine. These business rules will allow you to configure a rule to detect certain things, and those criteria, or certainly, or using certain criterias, and these criterias are something that you have to think about it, and you have to configure it and then keep up to date, as per the scenarios, because the scenario of fraud is very dynamic environment, right? The scenario keeps changing every couple of months, so you cannot be building a new rule every few weeks, because it takes time to understand what has happened and then build a rule out of it. Because it's rule, try to understand, rule is always happening after the fact. Unless you know that this is going to happen, you cannot create a rule, right? So it has to, if it has happened in the past, then you can carve that out as a rule, and then you can detect that as a pattern, a known pattern. Okay. Machine learning is, again, so the next level is the machine learning, where you can take out some of this manual laborious job, where you don't have to sit and build rules or define the thresholds or do all this analysis. Rather, you can just throw the data to the machine, obviously some trained data, and then you can use one of the algorithms, either classification or a clustering algorithm, to do further analytics. So if you have data which is already labeled, like which one are the fraudulent records versus non-fraudulent, then this type of data is called labeled data. And then this data can be then fed into one of the classification algorithm, because it's a supervised algorithm, which means you need to have a label in place. But sometimes you don't have the label in place, and if you still want to identify the behavior of these customers, or the policies or the claims, then you can use a clustering algorithm, where you're trying to group things together, but you're not pinpointing on one specific record at that point. So this is how much the industry has really advanced. People have started using machine learning already, and they sit side by side to the rule engine in the real world. The next level is the artificial intelligence, where you can use the deep learning algorithm. This is like a deep tech, where you can use like neural networks, and then, but what you really need for doing artificial intelligence is a lot of data. As long as you have a lot of data, this is going to work like a human brain, where it will be able to detect and do a much better job as compared to the machine learning algorithm. And the last part is the graph analytics part, which we are going to focus today. This is mainly used for community detection, link analysis, and various other things. So you are able to analyze the data in a form of relationships to identify fraudulent networks and people, right? Or organizations. That's what you can use it for. In terms of the use cases, there are various use cases for which the graph engine or the graph analytics can be used in the area of fraud detection. First one is obviously to do this community detection, to find out a fraudulent rings or the nexus where a bunch of people and the organizations are involved together in conducting the fraud. So that's like looking for a fraud pattern. Then once you detect the pattern, then you can find the influential entities within that group of people, or a network, that what exactly is it, really the customer, is it really a location, or is it the agent or the organization, like who's involved in this fraud. Okay. uh, and then once you so these are the two basic use cases. And then also we can use the outcome of the graph analytics, which is basically the predictions that you're making. They can be fed into the machine learning model. So today you may be already using machine learning, you may be having a certain level of accuracy, and if you want to become better, what you need to provide more insights, right? So your data, original data, is your data. I mean, it may have 50, 100 variables, but now to bring more insights, you need to bring better input. Only then it can generate better output. So we can use the output of the graph engine and feed it into the machine learning process, where it can get additional features for the model to train better and do a better prediction. So in a way, what I'm trying to say is, like, graph analytics can also augment, or it can also help improve your machine learning models, existing models. In terms of the interactive fraud investigation, obviously today you can throw a lot of data to the analyst and they can start looking all at the data. But if you put this data in a very relational aspect or in a network aspect, then I think the level of investigation can also be improved, because what you can see visually is 10 times better or 100 times better than when you see data in the form of a grid. Like, I mean, if you're looking at lots of different data points, then it's very difficult to wrap your head around it in terms of how this data is connected. But when you will organize the data in the form of a graph, you can do a better job at investigation. So you can enhance your investigation process by integrating, these graph visualizations into your system. At the end, last but not the least, you can also do the real-time fraud detection. So once you start really getting the value out of graph engine in the first 3 or 4 use cases that I'm talking here, then the final step would be to integrate in real time, right? Because everything you're doing at the top is in the form of batch. But what if you could detect your fraud in real time? But to do that, you have to integrate your existing systems to the graph engine so it can produce insight and feed it back to the investigator. So that's also a possibility which can be done. Let's talk about the insurance graph model. Now, graph modeling, in the previous webinar that was on the graph analytics, I did cover how to think about while creating a graph model, which is all about nodes and relationship. So here we have done the same thing. Based on the same concept, we have built a graph model. So the first step is to understand your business, and then out of that, you need to build your graph model, right? Like what is important for you from a business perspective. Because it's not about technology, it's about the business and its understanding, which is going to help you build this model. So this model, basically, you can see different nodes are available here. Each node represents some type of, it could be a person node, or it could be an organization, or it could be a location, zip code, address, phone number, pin code, anything. So each of these node represents one type of entity, and it is just showing you how all this is connected. So if I have to just take an example here, so this is a policy node, the green node, and a policy has a beneficiary. So we create a beneficiary node and connect to policy. A policy has a claim too, so it's connected as well, and so on. So you can see customer, claim, policy, beneficiary, office. Now you can also create subtypes of nodes. So for example, you may have different type of offices like branch office, head office, front office, back office. Now you can create different type of office. So the more you try to break down your model, the better the visibility you're going to have it. Obviously, you don't want to over engineer and try to see too many things. You need to limit with your business experience to what level you want to break down the graph, because the more the nodes you create, the bigger the graph is, and it will take more time to process. So it's a two-edged sword. I mean, it gives you a lot of insight, but at the same time, it can create performance issues. So I would recommend that you start something small, like 10 to 12 type of nodes, and then you start breaking it down as you need more and more information about that node. Graph algorithms. So there are two algorithms that we have used in the past in our experience while solving an insurance claim fraud detection problem. What you see in the left-hand side is the two different algorithms, community detection algorithm called Lubin, and another one is PageRank, where you are trying to find an influential node based upon the ranking of the nodes. And on the right side, what I'm showing here is this is basically a small subset of the graph, which is this graph represents, I believe, like 2 policies and 3 claims, and everything that's connected to those policies and claims. So this particular graph is color coded. So you see that there's a grouping of color. So all the nodes which are yellow in color, they belong to one community, and so on. Okay. So you can run the community algorithm, which is the Lubin algorithm, the one on the top left. And this algorithm will help you to detect the communities and the nodes that are a part of the community. And it's going to assign a community ID to each of the node. Once the ID is assigned, then you can use some kind of visualization tool where you can say all the nodes belonging to a particular community, mark it in a color red or blue or black, whatever you like, right? And so on. So that way you're able to visually now differentiate these nodes into different communities. And once you feel that, okay, I would like to focus on a community which has got the maximum fraud in it, then you can try to deep dive into it, right? From an analytics point of view. So it's really a combination of machine and human. It's not really that the machine will come and give you the final answer. It will give you enough information for you to go to the next step. Okay. Because let's understand, like, data science is all about probability, right? It's never 100%. Every prediction it is making with some level of confidence. And that's where as a human, we start investigating, and then we try to validate. And that way, the machine becomes better and better in subsequent cycles. PageRank is another algorithm. So PageRank will allow you to rank each of these nodes. So let's say if I have like 10 policies, and if I need to know like what should I focus on, then there has to be some representation in the form of a number, so we can compare and try to start focusing on a particular claim or a policy which has got the highest rank. This ranking is based upon the attributes that you're setting on the nodes. So it can only rank based upon the information that you're providing, right? So as a business user, or you need to be cognizant about what information you're going to provide on each of these nodes, because that is what is going to really drive to which community it belongs and what should be the ranking of this node. So in a nutshell, the communities is allowing you to create a focus area, and then once you focus in that area, the page rank algorithm is going to allow you to focus on a particular person or a place or a organization and so on, right? A particular node. Let's take an example. So this is an example that we have carved out from a hospital fraud perspective. And the assumption here is like there is a hospital which is involved in fraudulent claims. So how do you figure this out? So we wrote a query. Now, this is not based upon the algorithm. This is pretty much query driven, where we are writing a query saying, show me all the hospitals where fraudulent claims are involved. So you can see at the top one, there is one policy involved. There is one policy holder called John, who's having two policies, one on the left and one on the right. And for each of these policies, there is one claim, but one of the claim is a fraudulent claim. It was a claim where there was a death before the issuance of the policy. So the person was no more in existence and still the policy was issued. Now this can only happen if, it cannot happen on its own by the system. It has to happen if any employee of the company is involved, the insurance company, or maybe the hospital is involved who's issuing a fake certificate and so on. So this will basically allow you to start focusing on this. So this is your starting point, right? Because you already know that within this particular network, there is a fraudulent claim involved. And there may be a possibility that the other claim, which has been raised by the same person, may have a fraud involved in it. So the idea is not to detect which policy or claim is going to be fraud. The idea is to detect what is driving it, right? Who's driving it? Is it the organization? Is it an individual? That's what we are trying to analyze through this visualization. The example number 2, this is a location fraud. In this case, what we have done is, obviously, you are going to have many customers, and each customer is going to reside in some zip code. So on the extreme left, we are looking at a particular zip code, which is 48834, and this zip code has different types of relationships here. There could be an agent living at that zip code. There could be a hospital which is located at zip code, or maybe the customer itself is living at the zip code, right? Or there could be a pharmacy at the zip code. So we are trying to find out that how far is that, how many hops are needed to figure out between the zip code and a fraudulent claim. So if you see in this case, this is a zip code and here is the fraudulent claim which is sitting here. So to go from year to year, it may be pretty much like 4 to 5 steps. So the closer a fraudulent claim is to a zip code, you might try, the intuition you might develop is like, maybe in this particular location, there is something in common, could be a person or could be an organization, which is involved in a systematic fraud, right? So the closer the nodes, the higher the chances of having any kind of fraud in it. I mean, because there are policies which are already involved. I mean, there are claims which are already fraudulent to begin with, which belongs to this particular zip code, and there could be other claims which are pending, and they might also be a part of the fraud racket. So this particular visualization will allow you to analyze that information. Again, this information is available in the form of query. So once you run the query, you can see this piece of information. But once you look at this visualization, the next step is really to see to which community it belongs and what are the rankings on each of the nodes, so that you can find out what's influencing the fraud in the first place. This is an architecture diagram of a fraud detection system. This is how a typical graph analytics engine is incorporated in an enterprise. It starts from left to right. So on the left, as you see, there are source systems, which is having data about your customers and policies and claims. And this data then gets fed, the data is pulled and fed into the system. That system is the analytics system. So traditionally, it could be a rule engine. It could be just a basic rule engine, which is looking at all the data and generating some alerts or generating some kind of score. But in this particular case, what we are saying is this data can be fed into a graph engine. And this particular graph engine is going to generate insights based upon the algorithm we discussed, which can then be fed into a machine learning model. So it can augment your machine learning model. And once that is done, the machine learning model can be trained and implemented. So this is a process where the model training testing takes place, and then once the model is created, we can implement it. Now, there could be more than one model, right? There could be a model to identify customer risk or policy risk. There could be a model which could to find out fraudulent claims and so on. So it doesn't have to be like just one model. It could be a bunch of models that gets integrated in your downstream system. So there could be one system which is an operational system where you are issuing the policy. It's like an underwriting system. And this system is an investigation system, a claim system, where you're trying to investigate your claims. So obviously these models are useful in both the places, because in the first place you want to stop the fraud from being happening, and then once the let's say the claim is already initiated, then obviously you want to make sure your investigation system has all the information that is needed to predict whether this claim is a legitimate claim or not. So you can consume the results from the model into the investigation system, and then during the as a part of that investigation, you can also feed information through the graph engine directly, which will help to do the investigation in a very visualization manner, right? So as I was talking about, we can launch that particular graph, which will help the investigator to start navigating and seeing what are the relationships involved, like who's involved in that particular chain of fraud. Okay, so we'll do a quick demo now. It's going to be a very short demo. We have used a technology called Neo4j for the demo purpose. There are multiple graph products available out there. We can use Spark, we can use Neo4j, we can use Gephi. But for this particular demo, we have the concepts are pretty much the same, like what is a node, what is an edge. So I'm going to show you how we took the data from, I have created some data, like mocked up some data in an Excel. I'm going to show you how we cooked up the data and how the data was fed into a graph engine, and then how we were able to run the algorithm and detect the communities and the influential entities. Okay, so here is the sample data. So this is the data that we have mocked up for the demo purpose. We have taken like a couple of policies and claims and the data surrounding to those policies and individuals. So as you can see, we have cooked up some data on the address, customer. There are two different insured. There are a few beneficiaries for those claims, like for those policies, and then which channel they used and things like that. What type of hospital was involved, laboratory information, physician, any kind of office information, right? And then things like that. And in terms of the records, like who's the employee, what is their role in that particular policy and the claim process. And then what are the different reasons, like the fraudulent reasons that appear when the fraudulent claims takes place. What we do is we take all this relational information and then we feed this data into the graph engine in the form of nodes and edges. So the first thing we do is we create nodes. A node is basically let's say you identify address to be a node, then we are going to need what is the ID of the address and what is the name you want to display and few of the properties if you like. And then what is the type of the node, which is address, right? So this is how we create all the nodes data. Similarly for agents, hospitals, prescriptions, etc. And then we also create edges among those. Those nodes. So here you see we have created an edge between a customer and an address. Obviously, there is a concept of a source and a destination. So if you think like it is more relevant to connect customer to address, then you should keep your starting node as customer and your target node as address, and then obviously what is the relationship between them. So you can read out that way. So in this case, I'm going to say that the customer lives at an address XYZ, right? So similarly, for all the nodes in your data, you will have to create some edge. It will be very rare that there is a node out there which has no edges, because then it will absolutely provide no value, right? In terms of analytics. Okay. Now let's look at this is the Neo4j tool. It's a database, as well as they have a user interface where you can go and analyze the graph. So the first thing we have done is we have loaded all the data that I was showing you previously in the Excel sheet. Once the data is loaded, you can first ask for like a full graph, right? So you can say, show me all the nodes and edges that are present in the graph. Now, obviously, if you have millions of customers and thousands of claims, then you don't want to really pull the whole graph in one shot. It's not going to fit, and it's going to be very non-performing on the browser. So you can limit your query. You can just say, I want like, the top 100 rows or top 1,000 rows, whatever is, feasible for you for analyzing. So this is just to take a quick glance of the graph, like how does it look and, how do you access it? So in this particular case, I'm using Neo4j, which uses Cypher query language. Now you can click on any particular node here. This particular node, it says it's a zip code node. The ID is 10. This is an internal ID, and this is the ID that we have assigned, and what is the name on it, and what is a community and the rank. So I'll come to the community and rank as the second step. The first thing you need to understand is once you load the data, all the minimum information that you've supplied is already available in the graph database now. So that's why I'm able to, kind of read all this information. And as you see here, there are different types of relationship here. So for example, this is a policy, and this guy is an insured. So if you see, this is an insured node, and policy is connected to an insured, and it says insured for, right? So for between each node, you see there are many relationships here, and now our job is to start analyzing this relationship, run the algorithms, and generate insights. So over here in this graph, we have 105 nodes and we have 143 edges. Okay, this is just the data for like 2 policies and 3 claims. So you can imagine how this can explode, right? If you have millions of policies, then it could be like, like maybe more than 100 million nodes, etc. Right? So it could be a huge graph. So performance can be a big challenge, but I think with the right use of the technology and the machines, you can nail it down. And you need to be very smart at writing this query so that you're not fetching everything or boiling the ocean, right? So this is the first graph I have scanned through. Now the next thing I can do is like the other thing was the example that we were talking about, the hospital example. So here I'm saying like, give me all the hospitals which has ended up in a claim, which is involved in a claim. And and it has a fraudulent remark on it. So I am only interested to see hospitals which involves a claim which is a fraudulent claim. I don't want to see claims which are normal claim because there is nothing to investigate in it, right? It may be too early. It's not like they will never have a fraud in those cases, but it may be too early. In this case, you can see like, it is kind of displaying me a hospital, 2 hospitals here. One is Cosmos, another St. Jude. This hospital is insuring a person who's holding 2 policies, policy 903 and 902. And one of these policies have to be having a fraudulent claim, hence, because as per the query, right? So this is what the hospital query looks like in a cipher world where you are trying to get all hospitals which involves the fraudulent claims. Now, in this particular case, we are looking at only like 2 policies and 3 claims, so the data volume is very low. But if we had a lot of policies and claim, then we might come across some pattern which is visually very obvious to us that seems like this hospital is always involved when there is a fraudulent claim around. So the first step is you need to first find the communities, right? That is the step 1. Once you find the communities, then you need to find the influential nodes. And once you find the influential nodes, then you can start investigating in this fashion. So you can run the query from that node and you can start the investigation from that point. We are using another tool here called Neovis. This tool is basically, this is just an online tool. It's pointing to a JavaScript library. Here you can configure all your nodes and relationships, and you can run any cipher query. So I'm running a cipher query where it connects to the Neo4j database, and I'm asking like, show me the complete graph, right? Let's say this is the first query I'm running. Now I can go back to the browser and I can refresh it. Okay, so this is a graph this is the complete graph along with all the color coding. Each color code represents here's one community. So if I keep my mouse on one of these policy, let's say this is a policy node, you see the name is policy, the ID of the policy, the community's number is 0, and what is the page rank. So community and page rank is something that we generated out of the algorithm. These algorithms will help us group these nodes into communities so that we can focus our analysis on a certain community. And then once you are into a community, then you want to know who's influencing that community, right? Is it a person? Is it a place? Is it a hospital, organization, what not be? So the page rank will allow you to figure that one out, because the higher the rank, the higher the influence of that node within that network. When I say network, it's a community, right? So your step 1 is to find the communities and then the dense communities. And then once you find the community, then you can find the page ranking. Some other type of graph I can write here is, so I can look at a particular community, let's say community number 1. I can just query a specific community. If you see this is kind of finding me community number 1, which is blue in color. And then it is also giving me any external connections to outward connection to other communities, right? What is connecting us to another community, which is a different color. So now this is a particular community I'm focusing on. Now looking at this community, we might be interested to look at the zip code. Let's say we are kind of suspecting zip code in this case, then we can just focus on the zip codes, right? Like which zip code is the most influential. Okay, this is a list of all the zip codes we have, and then the size of the circle depends upon the page rank value, the scoring basically. So here you see that zip code 1001 has the highest rank, and hence it has a, it's a bigger circle in as compared to others. So you see the page rank is 1.18 versus if you compare with others, they will be less than 1, like 0.5, 0.59, and so on. So this kind of tells me when I look at all, if I was suspect, let's say the first thought comes in my mind that maybe I want to suspect hospitals. So the first thing I'll do is like I'll look at all the hospital nodes and see which hospital has the most influence. Then I can see which community it belongs to, and then I can query that community, right? So that is one way of analyzing. Another way to do it is first you can look at communities, and then you can look for the influential nodes within that community. Because you might look at the community, then you will look at the influential node. Then let's say you find out that, okay, zip code is the most influential node in that community. And when I look at all the zip codes, I again find out that this zip code is still responsible. I mean, it is still influential across all zip codes. So that kind of confirms me that my starting point of analysis should be a zip code, and to be more specific, 1001. And once you know that, then obviously this is the kind of query we can run. And in this case, there's a hospital instead of a zip code. And that's how we perform the analysis. So I think if you use these two different tools, one is the Neovis, which is a visualization tool, which connects to the Neo4j. And Neo4j is a tool which is holding all the data. Then I think with the help of these two tools, you can easily organize your data and do the analytics and run the algorithms. Okay. So going back to the presentation. Okay. So this brings us to an end of the webinar. I'm happy to take some questions if there are any. Please feel free to type your questions in the chat box and I can quickly grab it from there. Okay, so the first question I see, like, do we have to use the same type of node while calculating the page rank? Okay, so the answer is no, I don't think so, and we haven't done that. What you can do is you can still rank every node irrespective of the type of the node. And once you rank everything, you are certainly going to compare the nodes of the same types, like what we did with the zip code example, right? I was looking at only zip codes, and then within those zip codes, I see that zip code 1001 has the highest influence. In fact, you want to know, you cannot just look zip code and compare from a zip code perspective, because any connection that is coming into that node is, it has a reason. So if there are more number of connections coming to a node, it is certainly going to be more influential in a good or a bad way, and hence it needs to be analyzed. So I don't think so you should restrict yourself to a particular type of node while calculating page rank. But then subsequently, once the rank is calculated, then you might filter the data by node type and then do your analysis. So that could be a secondary thing, but doesn't have to be a primary factor to be considered. Okay, there's one other question in terms of the scalability. So the scalability depends really upon the technology you're choosing, because I understand your concern that for two nodes, or I mean, for two policies and three claims, we have created like hundreds of nodes. So there's like 100 times 100x effect. So if you have 1 million policies, we might be looking at like 100 million records. Yes, this can really get bigger in terms of size, and hence you need a proper technology to be chosen. So Neo4j, I would recommend, that's one of the technology. Or you can also use Spark graph frames. We have also used that in the past, which, I mean, both of these technologies are horizontally scalable. They can distribute the workload across the machine and run your query. So you can get the better performance out of it. Again, one other tip I would like to give, like, try not to over engineer your graph data model, because if you create too many nodes, then the downside is that you might be creating like millions of nodes just because of that reason. So it may have nothing to do with your data, but it may be something to do with your over engineering of the model, you know. So you can cut down the number of type of nodes. That can also bring down the volume of the data significantly down. Okay, we can take one other question. So the next question is about the hospital claim fraud, that how did we really conclude on it? Okay, so in terms of the hospital claim fraud, my suggestion would be like, it's really driven by the algorithm. It's not like I mean, in this particular example, we have cooked up the data, but ideally what you would do is like you would pump all the data into the graph engine, you will run these two algorithms. And I'm talking about these two algorithms specifically from a fraud detection perspective. So you run the Lubin algorithm, you get your communities. Once you know that, this a particular community has the highest influence, This influence can be for one of the two reasons, right? It could be because you are already suspecting some hospitals, but you're not sure. And that's why you are trying to search for communities based upon hospitals, which involves fraudulent claims. So that's a different way to look at it versus you have no clue and you're just picking up a random community to investigate based upon the density of the number of nodes in it and the number of fraudulent claims involved in it, right? Once you do that, then you can, deep dive into the influential nodes and you can start your analysis. So that's how we arrived to the hospital being a potential fraudulent or, something that's driving all these fraudulent claims or issuing, fake death certificates, etc. Okay. So that brings us to the end of the webinar today. Thank you all of you for joining, and we are happy to help. If you have any questions or answer any questions, feel free to reach us out on our through our website. Either you can go to inferyx.com or you can contact us through our email ID, which is listed here on the presentation. You can also call on this number, and we can take your call and we can schedule a call with you to discuss your, if you're facing any challenges in terms of technology or in terms of solving the insurance claim fraud analytics problem. We have already worked with a company in this area, and we are happy to share our experience with you and what we have achieved. And then we can take it forward. Okay, thank you everyone. Have a great evening. Thank you.